All right. So welcome to the Public Opinion Quarterly Special Issue Webinar, Augmenting Surveys with Paradata, Administrative Data, and Contextual Data. This session is being recorded and will be posted to the DC-AAPOR YouTube channel in the next couple of days. Today's webinar will feature the editors and authors of the 2023 special issue of POQ. Thank you all so much for joining us today. I'm Melissa Sedade, your host for the session. This webinar is brought to you by your DC-AAPOR Program Committee. Thank you to all who helped organize the event today. And today's order of operations will go as follows. First, we'll hear from the editors, then each of the authors who will present for about 15 minutes, then we'll circle back to our editor. During presentations, please mute your microphones and use the chat feature in Zoom to enter thoughts and questions. We'll have 5 minutes for question and answers after each presentation. And I'll be watching the clock closely to ensure that we have a chance to hear from everyone. Once all of our speakers have finished, we'll open the floor for further discussion. If you're comfortable, please feel free to turn on your camera and ask your question or provide your feedback directly. So it's now my pleasure to introduce our first presenter, Bella Struminskaya. She's an associate professor in the Department of Methodology and Statistics at Utrecht University in the Netherlands and a researcher at Statistics Netherlands, and she'll be kicking off our session when you're ready.
Thank you so much, Melissa. And I will just share my screen. Let's see. All right, I hope you can see it now. So it was such a pleasure to edit this special issue with Joe Saxhog, who unfortunately isn't here today due to a scheduling conflict. So it is on augmenting surveys with Paradata, administrative data, and contextual data. And I will just give a tiny introduction because I don't want to eat up the time of the presenters who will talk about their papers from the authors. And just a couple of definitions to for us to understand what we mean when we say Paradata, when we say administrative data or contextual data, because these data sources are rather new and some of them maybe we understand a bit differently, or how we conceptualize them is a bit differently than others. So Paradata are data that relate to the process of collecting survey data during the field period. So these are not answers which are obtained directly from respondents, but a byproduct, if you will, of the data collection. And the examples of such data include call records or keystroke data, also interviewer observations that are in some surveys collected routinely, in web-based surveys are easier to collect than in face-to-face surveys, well, generally keystroke data, for example, and used for various purposes, such as to, for example, correct for non-response or also improve questionnaires. Administrative data are the data that are externally created and often linked to individual respondent records by matching personal information. So you can think about data from the tax registry or insurance registry or voter registry data, but it does not necessarily have to be only registry data. It can also be data, for example, in organizations from the administration, such as the universities, let's say students' grades. Contextual data are, maybe this one is a bit less well-defined, and how we understand are external sources of information that measure various aspects of respondents' physical, social, or informational environment. So this can be data on neighborhoods, for example, external records, or it can be data collected through devices such as smartphone sensors, like geolocation, for example, from apps on usage of the apps by the participant, or whereabouts on their physical activity. That can also be digital traces. So, for example, web tracking on which websites people visit. And this can be used as objective data. So, for example, to study voting preferences, looking at media exposure to news related to politics. And they have an advantage of well, being fine-grained, being very detailed, and also not having socially desirable responses as we sometimes have in surveys. So there are potential benefits and advantages of all these data sources, which are becoming more and more widespread. And we think that the breadth of research and the wealth of research is going to grow. But there are also challenges. And some of these are selection issues, because, well, the records also can be missing consent issues. So for this, for Paradata, for digital trace data, and other contextual data, respondents need to provide consent. We, as I said, objective data, we assume that this is objective, but the measurement accuracy and measurement properties are, well, not so well studied. And also there are some data collection issues. So for example, for digital trace data, it is only few studies now use it in combination with surveys. So in this special issue, we have 5 excellent papers which showcase this innovative research using one or more of these survey enhancements. So some papers combine it, and they address important questions in survey research. And with this, I want to hand over to the authors and then come back to tell you about the piece which Joe and I wrote on the ethics of augmenting survey data.
Thank you so much for that. All right, now I'll invite Tobias Gummer to talk with us. Tobias Gummer is a survey researcher at GESIS, Leibniz Institute for Social Sciences, and a professor at the University of Mannheim. And when you're ready, we're ready to listen.
All right, thank you very much for the very nice introduction, and thanks for having me. Well, what I'm presenting today is our paper, and it is joint work together with Tanja Kunz and Tobias Rettich and Jan Karem Höhner. Well, I guess many of you have seen questions on political knowledge like the one presented here. It's taken from the ANES, and well, you ask about factual knowledge of your respondents to try to gauge that. If you ask about political knowledge in web surveys, well, you don't really know what you are capturing. You could, there is basically knowledge about the information, the factual knowledge. You know the information, and you can give the answer. And sometimes you simply know where to look and how to find the information needed to answer the question. So the one is declarative memory, and the other is procedural memory. And in most cases, we're actually interested in declarative memory. And if respondents in web surveys take the opportunity to simply switch the window and look up the answer, the measure of declarative memory becomes confounded with procedural memory. I believe there's lots of research on that, and just a few papers here, and many of these are from the US context, so I guess you are familiar with these. And they pretty much show that looking up answers in web survey confounds the measure, and it also confounds the models and what you do with the data. And if you start diving into the literature a bit, and you'll find also like a string of research that is looking into instructions. And we were quite interested in this research because instructions to respondents seem to decrease the likelihood that respondents looked up answers. For example, by using discouraging statements like, you should not look up the answer, simply give your answer as you know it, or actually asking respondents for their commitment to not look the answer worked pretty well, especially the commitment question. Well, made us interested in checking that out in more detail. So respondents were asked to click yes, I do. Please, do you agree not to look up answers? And they agreed to that and committed to doing that, or maybe not. And previous research showed interesting effects of that. But these are ways to prevent respondents from looking up answers. And another thing of investigating looking up answers is focusing on the measure. You want to measure looking up answers of your respondents, basically to check your data quality, maybe to controlling models, or even correct your data by getting rid of respondents who looked up answers. If you dive into that line of research, there's the different measures you can use to look up to measure lookup behavior. And the first one is self-reports. So self-reports, you ask the respondent, well, did you look up the answers to the knowledge questions? And they might answer honestly. But some research is suggesting that there's social desirable responding going on, and this might bias your self-reports of lookup behavior. So a different line of research suggested using Paradata on Windows switching. I think that this was the way for us to get into this very nice special issue. And Paradata, as Bella already defined it, on Windows switching can be collected by using some kind of JavaScript, for example, in your web survey. And if you dive more into detail in this Paradata, so Windows switching Paradata, what it captures, the way we measure it is you have your pretty old school screenshots here. So you have your survey browser window tab on the left side, and people start switching away. So they are losing focus, and you can measure if they switch to a Wikipedia page, for example, and start looking up the answers. But what we do not capture with these data is what they do. So we simply know that they left the web survey for a couple of minutes maybe, and then came back, but we do not know what they did. So which websites they focused on. And this basically brings up some potential issues with the Paradata measure of lookup behavior, because maybe respondents do not look up the answer, but we measure that, right? So we get a measure of someone Windows switch, and we assume they look up the answers, but maybe they are just browsing the internet, checking emails, engaging in social network activities, whatnot. And this would be the bias of our Paradata measure. And also, one could assume that respondents have different devices at hand, right? Like, right now, I'm speaking into my computer, but I got my smartphone here, and well, I could look up answers on a different device. So the Paradata measure, focusing on the window tab that I'm doing the survey in, will not be able to track multi-device multitasking. So this also might be an issue for Paradata. And we were wondering, should we combine self-reported and on-device Paradata measures somehow to cope with that? So this is where we started, and this is how we gather different research questions that we wanted to investigate here. And our first pretty basic research question was focusing on the instructions a bit. We wanted to know how different instructions affected respondents' tendency to look up answers. And here we strongly focus on comparing different lookup measures. Okay, so again, like we looked at self-reports, we looked at Paradata, and we also investigated how different how a combination of both worked. A second question was, well, it's pretty nice to have a measure of lookup behavior. If it does not predict correct answers in any way, it's pretty much worthless, right? Because what we want to know is if people really looked up the answer and gave a correct question, so they actually used their procedural memory and confounded our measure of declarative number. And our third research question was pretty much hands-on. So which measure should we use? Should we use the self-report? Should we use the Paradata measure, or even the combined measure to detect looking up answers? And as a brief disclaimer, so our paper is packed with analysis. So I'm really just focusing on the major ones here, and yeah, there is more in the paper than this presentation. So our experiment, so we did an experiment, was placed in the German Internet panel. It's a probability-based panel that was drawn in 2012 and had refreshment samples It's a web-based questionnaire, so web mode only, and it was fielded in 2021, at least the way the experiment was fielded in 2021. So our experiment consisted of 3 political knowledge questions, and we included JavaScript to capture Paradata switching. Our cases were roughly like 4,400, and our experiment goes like that. So we had 4 experimental groups, and the first group is a control group. So this group they just got the 3 knowledge questions, and that's it. The second group, they got an encouraging statement, because we're interested in, well, the opposite of discouraging people to not look up the answers. What would happen if we encourage them? Please use the internet to answer the question. And the third experimental group had a discouraging statement, so please do not look up the answer. And the fourth group had the commitment, had a commitment question where respondents actually committed to not look up the answer. After that, we had a self-report where we asked the respondents to state whether they looked up the answers, and then a follow-up question if they said, yeah, well, I looked up the answers, on which device they looked up the answer. And as I said before, we are pretty much interested in the measures of lookup behavior. So we had a measure for self-reports, we had a measure for Paradata for the 3 questions each, and we created a combined measure. For the combined measure, we used a rather straightforward method of combining. So we used either the self-report or the Paradata measure that was higher. So we expected that a high self-report measure would be very valid, because respondents overcame social desirability. Well, on the contrast, we used the Paradata measure if the self-report measure was lower, because we thought, well, maybe they were not inclined to give us the true answer because they felt socially pressured, and the Paradata should be more accurate in that way. Again, we created a measure where the respondents looked up the answer to one of our 3 political knowledge questions. Coming to our first research question, so do instructions affect respondents' tendencies to look up answers? Got that here, so that's the table. You don't have to read the table really. I got like small bubbles showing the results here. What we see is that across all different Paradata measures in the encouragement group, where we encouraged our respondents to look up the answer, in contrast to the control group, we see an increase in the number of lookups as measured by self-reports combined measure. And we also saw an increase in the number of correct answers. So respondents did look up more, and they actually answered better, or more correct, if you want to say that. In the discouragement experimental group and in the commitment group, we saw that the number of lookups was reduced in contrast to the control group, and also the number of correct answers was reduced in contrast to the control group. So we see an effect of the instructions, as previous research has shown, but here you can see it based on 3 different measures for lookups, and it's rather consistent, I would say. Okay, so what are these measures were? So do they actually predict the correct answers? And for that, we did some regression analyses, and I just brought the plots. So you don't have to start reading in detail. These are 3 plots for our 3 Paradata measures: self-reports, Paradata, and the combined measure. What you would expect if there's a correlation between the number of lookups as detected by each measure and the number of correct answers, there would be a positive slope. And you can pretty much see that in the top left plot, the self-reports across all the different experimental groups. You can see that the more lookups were measured by self-reports, the more correct answers were predicted. For Paradata, the picture is a bit different. So the box should showcase that. You can see that for 2 experimental groups, there's basically we detect more lookups, but these do not necessarily explain or relate to giving more correct answers. So there's more to the story here. We do detect lookups that do not help us to explain the answer, the correctness of the answer. And that is an issue, and it hints to the fact that we do measure stuff with the Paradata that we do not want to measure. So it does not perfectly measure lookup behavior. And you see the same pattern in the combined measure, obviously because like Paradata is part of that measure. And that brings us to our 3rd research question, where we basically focused on the question, which measure should researchers use? So self-report, the Paradata, or the combined measure. And well, we did a couple of different analyses for that. So when we first started out with this line of research, we had like the feeling that the higher the detection rate, the better. This was pretty much a result of us thinking about social desirability bias in self-reported measures. But while doing this research, we came a bit, we questioned that and did some more analysis. But if you would just go for a high detection rate, the combined measure, well, how it is built, the maximum of either, achieve the highest detection rate, higher than Paradata, which is even higher than the self-reported lookups. That's basically true for all experimental groups, except for the inclusion group. But as I already showed you, there's like, if you look at the predictive quality of this measure to explain correct answers to the political knowledge questions, and you look at the model fit, the picture changes a bit. So the combined measure achieves the best model fit, larger than self-reports and larger than Paradata. So Paradata has the worst predictive quality, and that's again an issue with Paradata. There seems to be noise we measure with this Paradata that is actually not lookup behavior. To go more into detail and learn more about these issues with the Paradata measure, we have the self-reports on which device was used to look up the answer. And those who reported to have looked up at least one question, and 30 of these, 30%, reported to have looked up the answer on a different device. And this is not captured by on-device Paradata. So we would have somehow to track the other device to gauge that behavior somehow. And this is not what the Paradata measure we used. That's easy to implement capture. So that's an issue. To summarize and to give an outlook for further research we are doing or planning on doing in that regard, well, we were really surprised how well the instructions worked and how well they worked, even if looking at different measures of lookup behavior. And we were especially interested in the commitment group before doing the experiment, and it actually reduced lookup behavior the most. So we were really surprised to find that, and it's a very good finding, I think, for survey researchers, because it's a tool that is easy to implement, and it has a big effect, I would say. And we also found that self-reports and Paradata, none is a perfect measure. So our recommendation in the end is to combine both measures. Maybe you find better ways of doing that than we did. We did like this very simple way of selecting either the highest of both. And I think there's maybe smarter ways of doing it. That's a subject for further research. And we were asked what we're doing now in this regard, and which research we are doing right now. So we conducted an experiment with knowledge questions again in a web survey, obviously, and that included web tracking. So we are going one step further. So we will have like self-reports of the respondents. We looked up the answers. We will have Paradata that give us a measure of window switching, and we have web tracking data of these respondents. So we know where they went. Okay, so we know which website they opened, and we can basically validate the Paradata measure a bit more and see how much email sending, how much social networking activities we're tracking. But this research is pretty much ongoing at this time. We also currently planning an experiment on using the commitment statements for further research purposes. So not really for looking up answers or preventing that. We're looking into using such commitment statements to improve respondent attention, for example, for selected questions, asking respondents to commit to really focus on the next couple of questions, give their best to answer it. And we'll try to test whether this helps to enhance answering quality. Well, there's even more work that could be done. We're not currently in the process of really going there, but for the future, we wrote it down if we found the time. So I mentioned that throughout the presentation, we would like to investigate different ways of combining lookup measures, and even web tracking might not be the optimal solution, because 30% in our survey looked up answers on a different device. We would require web tracking for these devices too. So maybe there's even a problem. And in the end, it's not always feasible to have web tracking in all our surveys, right? So it might be a good idea to look into Paradata and improve that measure, because it's cheap and it's not that much of a burden for respondents. With that, thank you very much for your attention.
Thank you so much. That was fascinating. So I do have a question from the chat. Does the tab switching JavaScript capture behavior on desktop and mobile?
Yeah, I believe so. So you can also have that for mobile respondents. Yeah, yes, yeah.
It's the same sort of functionality. Oh, interesting.
Yeah,
okay.
Yeah.
Yeah. Are there other questions? We have a couple of minutes that we can spend here if there are other questions. I found myself thinking about a few years ago, there was a big study that came out on religious knowledge, where respondents were asked sort of the same thing: is their top of mind religious knowledge versus looking it up? And one of the big criticisms of that study was that just knowing the knowledge didn't necessarily translate to understanding or action, right? And I just wondered if you could address that real quick.
Yeah, sure. So you could basically ask similar questions for all kinds of knowledge questions, where you're interested in having the factual knowledge, the declarative memory, or if you're interested in the procedural memory. And in that case, someone would be interested in procedural memory a bit more, right? So this is also why we were interested in the testing this encouragement experiment group, because we thought, well, maybe it's not really about facts. For example, if you ask me crazy stuff about Germany, I would be like, well, I don't know, but I could look it up. And right. Sometimes that's what we want to know, right? Because times are changing, and maybe factual knowledge is not really the thing you want to capture. You want to see how people actually use Google search or I don't know, ChatGPT to gather answers.
Oh, interesting. Yeah, thank you. Other questions? All right. Thanks again for your presentation. That was terrific. Let's go ahead and transition to our next speaker. Now we're going to hear from Iva Tasseva, an assistant professor in the Department of Social Policy at the London School of Economics and Political Science. Whenever you're ready.
Thanks, Melissa. Just trying to share. Can you see my screen?
Sure can. Thank you.
Yeah, great. I'll try to make it full screen. All right. So Thanks very much for organizing the event and the opportunity to present to you. So this was joint work with Chris Bollinger, and in this paper we examined income reporting errors in Austrian household survey data, which have been linked to administrative records. So I'm not gonna talk at all about why survey data on household incomes are important. I'm just going to assume that this audience knows that they are important, for example, for measuring poverty, inequality, and a whole host of other questions in the social sciences. But so to study errors in survey incomes, we need linked survey and administrative data. And typically in the literature, it is assumed that the administrative data are true incomes. So that's the approach that we adopt here, and we use the Austrian version of the European Union Statistics on Income and Living Conditions, that's the SILC, survey data which have been linked to administrative records on state unemployment benefits and earnings. And so we have two goals. The first one is to assess the extent of misreporting across unemployment benefits and between benefits and earnings. And we document that many respondents fail to report participation in one or more of the unemployment programs, and they also record benefits in the wrong benefit category. Furthermore, they seem to report at least some of unemployment benefits as earnings. So they seem to inflate their earnings for periods when they are actually unemployed and receiving unemployment compensation. And then our second goal is to examine the impact of this misreporting for how much education and job training leads to higher earnings. And we find that the returns to education and training are substantially underestimated with the survey data compared to when using the administrative data. So just very briefly on previous research, so there is a large body of literature that shows that cross-sectionally, social security benefits and earnings are misreported in survey data. And this paper here by Angel et al. Uses the same Austrian SILC data that we use, and they show that total income may be better reported. In other words, respondents may know better their total income rather than the individual income sources they receive. But we don't know if benefits are confused with earnings. If so, total income may indeed be better reported. So if respondents confuse benefits for earnings, then their total income might still add up to the same total, but incomes will be reported in the wrong category. But this matters. Correctly identifying separate income sources is important for many research questions. Okay, so we examine 3 unemployment benefits that exist in Austria and that are covered in the SILC. So the first one is the unemployment insurance, that's the UI benefit. The second, unemployment assistance, UA, and the third, assistance for covering living costs, ACLC. All 3 benefits allow for limited labor market participation. UI is the main program. It's an insurance-based benefit. So it means while you're working, you pay social insurance contributions. So if you lose your job, you can receive this benefit. And the benefit is only for limited duration, and job training may be required. UA is a much smaller program. It covers low-income groups and only kicks in once entitlement to UI has been exhausted. And you can receive the benefit for as long as you need. And job training may be required. And lastly, ACLC provides support for job training for low-income groups and can be received together with UI or UA. Now, all I want you to remember from this slide is that UI, which is the insurance-based benefit, is by far the biggest program, while UA and ACLC are much smaller programs that target low-income groups. So why might respondents confuse different programs and report benefits in the wrong benefit category? Well, we can rule out as a reason that program names are similar. They are not, they're very different in German, but benefits are conceptually similar. So all 3 benefits are paid for unemployment and they're paid out by the same labor market agency. and benefit amounts are linked. So UA is a percentage of UI, while ACLC is the difference between UI or UA and a minimum income threshold. Survey design might also mean that respondents find it quicker to report everything as a single benefit, so to shorten the duration of the interview. And also, people may not know the individual benefit amounts, but just the total benefits they receive. Now, why might respondents report benefits as earnings? Well, one reason might be that people feel stigma about receiving certain benefits. In particular, when it comes to UA and ACLC, which target low-income groups. So respondents may deliberately report these benefits into earnings. Another reason is that people may think conceptually of benefits as earnings. So, for example, UI and UA are linked to previous employment, to previous earnings. ACLC then pays for job training. So people might think of ACLC as a type of earnings in return for doing training. And all three benefits allow for limited labor market participation, meaning you can earn a bit at the labor market, so people might think of these benefits as a top-up to their wages. Now, as with program confusion, survey design might mean that people find it quicker to report everything as earnings. That's the first question that appears in the survey interview. So to shorten the interview duration. And again, as with program confusion, respondents may not know the individual amounts, but their total income. Now, our data don't allow us to identify the exact reason, so it might be a mixture of these things, but we think it's just useful to kind of think through the potential explanations. So we're using Austrian silk data, which are widely used by social scientists and underpin the official statistics in Austria on income, poverty, and inequality. And silk data, the survey design used for the silk, is also used in many other European countries, in about 30 other countries. So our findings extend well beyond the Austrian context. And the data are also used by international organizations such as the World Bank to track, for example, global progress in inequality and poverty reduction. The data we use reflect annual incomes for 2007 to 10, and the sample is based on private households registered in the Central Population Register. So what's crucial here is that the silk sampling frame, based on the central register, it's also the register used for the administrative data. So what this means is that we have a very high linkage rate. So for more than 95% of respondents, we have successfully linked survey and administrative data. And the data are a 4 years rotating panel, so each year 25% of the sample is renewed. So we observe people for 1, 2, 3, up to 4 waves. Okay, so this is just a 2x2 table showing you different misreporting types that we use throughout our analysis. So here we have administrative receipt and non-receipt, and survey receipt and non-receipt. So we get these 4 combinations where we assume that the administrative data are the truth. Okay, so now I'm going to show you 4 tables with results. We have more results in the paper. Okay, so this first table shows the extent of misreporting of benefits and earnings. So if you look at the first 4 columns here, here we show the false negative rates in benefits, and these are substantial. So for example, if we look at UI, only 43% of respondents who receive UI according to the admin data don't tell us about it in the survey. Now, if we look at false positive rates, these are much lower, they're less than 1%, but here the denominator is much larger. It includes everybody who doesn't receive a benefit according to the admin data. So in percentage terms, the false positive rates are low, but actually if we look at the number of observations, these are not an insignificant number of cases. For earnings, we estimate much lower false negative and higher false positive rates. So earnings are misreported as benefits are, but the misreporting patterns for earnings are somewhat different than for benefits. Okay, now this table is a bit bigger, but I'm gonna walk you through it. So here we are looking at combinations of survey income receipt given administrative receipt. And there are two things that I want to highlight. The first one is that we show that benefit false negatives seem to be reported into earnings, and benefits seem to be reported in the wrong benefit category. Okay, so now, first of all, for each row, the columns here, the column values add up to 100%. We have missing values for where we have few observations, so we can't disclose those values. And the diagonal shows the true positive rates. So ideally, this would be equal to 100%, but they are far below that. And most notably, this fourth column, earnings only, is the one that is kind of interesting. So it really shows that where we have benefits underreporting, this seems to appear in the earnings only category. So to give you an example, if we look at the first row, so here of the respondents with UI only according to the administrative data, which we treat as the truth, 38% only tell us they receive UI only in the survey, but 11% report earnings only instead. So, and we see that for other combinations of benefits and earnings. So to us, this suggests that earnings are being inflated while benefits underreported. The table also suggests that cross-reporting of benefits might be problematic, might be a problem too. So for example, of UA-only recipients, according to the administrative data, 11% tell us they received UI only instead. So respondents seem to be confusing the benefits they are on. Okay, these are cross-tabulations. In the paper, we also run linear probability models where we control for a range of household individual survey characteristics, and we show consistent patterns with this. So the two tables I showed you, we are looking, they show patterns of misreporting of receipt, but we also look at misreporting of the amount of income. So to kind of examine overall reporting behavior. So this table examines misreporting in the amount, in the exact euro amount. So here we have mean survey amount, mean administrative amount, and the difference between the two. So this is the error in amounts for separate benefits, benefit types, for earnings, and for total income, which is the sum of benefits and earnings, conditional on a benefit receipt and report. And this table is for UI. In the paper, we also have results for UA and ACLC, and results are consistent. So the main thing that I want to highlight in this table is that we show that while on average people misreport benefit and earnings amounts, it seems that the errors that they make in individual income sources partly offset each other. So the error in overall income is smaller than for individual income sources. So for example, if we look at this part, so conditional on UI true positive, UI is being misreported by 185 euros plus 185 euros, while UA is being misreported by minus 156 euros. So they partly offset each other. So the error in total income is only minus 44 euros. Now, another way to see this is in this table, which shows the relationships between misreporting in earnings and benefit amounts. So here we have the error in total benefit amount. So that's the difference between the administrative and survey amounts, while the our outcome variable here is the error in earnings, the difference between survey and administrative earnings. And a coefficient of 1 indicates a euro for euro transfer from one income source to another. So if we look at this first column for men, what this coefficient means is that men seem to report benefits 1-for-1 as earnings. Now for women, the size of this coefficient is half of it, is 0.5. So in the paper we show that women seem to be kind of better at reporting, but both men and women make reporting errors. Then in columns 2 and 4, we break down the errors in benefits into 5 categories. And so, for example, we show that for false negative men, again, they seem to report benefits 1-for-1 as earnings. Among those with true positive benefits who underreport benefit amounts, 2/3 of missing benefit amounts seem to be reported in earnings, and so on. And again, the coefficients for women are slightly smaller, but again, we show that both men and women misreport benefits as earnings. Okay, so in the paper, we also look at the implications of misreporting for important research questions. And we note in particular the long-term interest of researchers and policymakers in understanding the returns to education and the efficacy of tying unemployment programs to job training. And we show that misreporting biases our estimates for the returns to education and job training. So we can demonstrate that in the paper. Okay, so I'm just going to conclude, just to recap what I've told you. We show that all 3 unemployment programs that we examine are underreported in the survey, and respondents seem to misreport benefits in the wrong benefit category. And they also seem to, while they underreport benefits, they also seem to overreport earnings, suggesting that they put some of benefits into earnings. On average, people make mistakes in the amount they report for different income sources, but the error in total income is smaller. So that suggests that respondents seem to know their overall income better than the amounts for individual income sources. And our findings extend well beyond the Austrian context and the misreporting of unemployment programs. There are important implications for a range of research questions. And we note also that common strategies used by statistical agencies to correct reporting errors in survey data might be particularly problematic. For example, if analysts replace only one income component by an accurate admin measure, for example, just for benefits, but not for earnings. So a better strategy might be to correct the sum of income components rather than just focusing on one particular income. And just finally, I just want to share that we've continued, Chris and I have continued working on this topic. So we now have a new working paper, The Persistence of Income Reporting Errors in Household Survey Data, where we leverage the panel dimension of the Austrian silk. And one of our key findings is that longer periods on benefits seems to be associated with misreporting benefits as earnings. So our finding in the POQ paper seems to be driven by the panel. We also demonstrate that when respondents make an income reporting error in one wave, that increases the probability of them making an income reporting error in subsequent waves too. So past reporting, past errors are predictive of current survey reports. And then we demonstrate the implications of this misreporting for estimates such as for poverty transitions and persistence. Okay, that's all. Thank you very much.
Thank you so much. That was terrific. Let me just check the chat. Okay, I don't see any questions in the chat, but I found myself while you were talking. First of all, I was blown away by your number that 95% of your respondents have survey and admin data linked. That was incredible, right? To have that kind of link. And it led me to be thinking about, are we moving toward a world where we maybe don't even ask these high misreported questions, where we rely exclusively on the admin data? And can you speak to that?
Right. Yeah, I think that's interesting. I think probably we are not there yet. I think many countries don't yet have, for example, the infrastructure to allow for the linkage of survey data with these different administrative sources. That said, I think many countries are doing some progress in that direction, but I think there are issues. I don't think that administrative data will, I think there's still a lot of value in collecting survey data. And I think potentially, combining survey data with administrative data on a range of income sources might indeed kind of improve the quality of data. But I don't think we will be replacing entirely survey data with administrative data, if that makes sense.
That's terrific. Thank you. Great feedback. All right, let me pause here and see, are there any other questions that folks might want to pose? All right, terrific. Thanks again so much for your contribution. Let's keep this moving. So next up, we'll hear from our next speaker, Rebecca Andridge. Rebecca Andridge is an associate professor of biostatistics at The Ohio State University College of Public Health. And when you're ready, we're ready.
Thank you for getting the V correct. So I'm going to try to go through this a little bit quickly because I'm really interested in hearing what Bella has to say about the ethical challenges. So I'm going to try to keep to my 15 minutes. So this paper was joint work with Brady West. Brady would love to be giving this talk, but he is in Australia right now, so the timing doesn't really work out. So I always like to start with a little bit of amusement when I give talks. So this paper is about pre-election polling, and I'm sure there are many of you on this Zoom who have had this feeling before or have been bearing the brunt of people feeling this opinion. So 4 and 5 don't trust Washington, 9 and 10 don't trust polls. We've got the science of polling, which is perhaps just witches brewing around a pot, and poll workers going to see the migraine specialist. So in the United States in 2020, there was this sort of polling crisis, right? It was the highest error in 40 years. It was a failure of polling. And it didn't seem to be the same problems as polls had in 2016. So in 2016, there were things that were going on that essentially weren't happening anymore in 2020, or at least were not as big of an impact. For example, lots of people early voted in 2020. And so the sort of late decision, changing your vote wasn't as much of an impact in 2020. The weighting methods to account for non-response and non-coverage in the polls also got better, I would say, in 2020 compared to 2016. For example, education being used, which is a really important predictor. And so we're sort of getting better polling techniques in terms of the adjustments, but huge misses in these polls. So what Brady and I work on a lot is a problem of polls and probability samples where we have really, really low response rates. And so generally speaking, we conduct a survey, we get some non-response, and we wait to adjust for it. That's great when the non-response is 10%, 15%. It's not so great when the total response rate is 10% or 15%, right? So when you have a sample that just has this enormous amount of non-response, we really essentially argue that you can't treat that like a probability sample anymore. So these polls that were analyzed in this paper had response rates in the around 5%. That is incredibly small, although pretty typical for this type of polls. So when we do weighting adjustments, which is what are done with these poll data, they're assuming that selection and response is at random. So that means conditional on the variables used to make the weights, a person who chose to respond and a person who chose not to respond are exchangeable, right? We can imagine that's what we're doing with this weighting. The issue is that in 2020, when we are talking about political polling for the presidential election in the United States, there might be something else going on. So we argue that Trump supporters in 2020 might have been less likely to answer the poll, even conditional on demographic characteristics. So 2 individuals of the same age, of the same gender, of the same race, but one a Trump supporter and one not, we're arguing that perhaps that Trump supporter is less likely to participate in this poll. So one final cartoon, here we have the election poll work and the man says, should I put you as genuinely undecided or damned if I'm telling you undecided? So that's the kind of non-response that we're worried about. We're worried about this idea that whether or not someone participated in this poll is related to what their answer to the poll question would have been. And this is the conclusion that an AAPOR task force came to in a sort of postmortem on the pre-election polling failures in 2020, with this quote that the Democrats and Republicans who responded had different opinions than those who did not, right? So this is a problem because weighting isn't going to fix this problem. This is what in the missing data literature is called non-ignorable missing data. And thinking about selection bias for non-probability samples, it would be a non-ignorable selection bias. So we have this sort of three-pronged statement here. Our goal is to estimate a population proportion from what we're going to treat as a non-probability sample because of that about 5% response rate. We're trying to estimate the proportion of people who are going to vote for Trump. The problem is we believe there's probably some selection bias that is non-ignorable because the response to the poll, whether or not you participated, might depend on the candidate preference. So in this paper, we apply a method we had previously developed called the index. It's an index of selection bias, the MUBP, measure of unadjusted bias for a proportion that allows you to essentially conduct a sensitivity analysis and say, here is our estimate, assuming that the weighting is working. And what happens if we assume that response to the poll depends on who you are supporting by a little bit, all the way ranging to by entirely dependent on your candidate preference. So this is a sensitivity analysis. So we're just going to see kind of a range of possible truths. And one of the things that's nifty about this particular sensitivity analysis is that the extra data you need, right, the auxiliary data necessary is the same auxiliary information that you're going to use for weighting. So it doesn't actually require doing some kind of merging or pulling data from some other source. So we're estimating the percentage voting for Trump. The paper had analyzed a lot of different polls. I'm just going to show you the results from the ABC Washington Post, 7 different pre-election polls conducted around October in 7 different states. These are RDD surveys, again, very low response rates, and weighting adjustments were done, right? Every attempt was made to get the right answer with weighting for these polls. This is a situation in which we have the truth because the election happened, and so we know what the proportion of voters who voted for Trump is. The tricky part of this situation is this population of likely voters. So before I started working on this particular application with Brady, I didn't know anything about likely voters and likely voter models. It's a thing, right? It's a real challenge, and people make their entire career, so far as I can tell, trying to come up with predicting that someone is going to be a likely voter. This is a really tricky challenge. I feel for the people who have to do this on a daily basis because it's really hard to figure out population summaries of a population that is dynamic, right? Who is a likely voter is not the same as who is an adult male, over 18 in the US, right? A much more stable population. So when we're thinking about applying this method set to do the sensitivity analysis, we have microdata on the selected cases. So this is the poll respondents. We know who they've indicated that they're going to vote for, and we have auxiliary information, questions asked on the poll: age, gender, education, race and ethnicity, party ID, and ideology. The auxiliary information that we need is information at the population level about all likely voters in the US. So we'll call this Z, and we need a Z bar, right? We need the averages for Z, and then we need a covariance matrix. So because the polls are really small relative to how many people vote, we can essentially think of this as getting it on the full population instead of just the non-poll respondents, like everybody who's a voter but who's not in the poll. The problem is my question marks here, the source. Where are we going to get this information? This is a really tricky problem. So what we ended up doing is looking at a bunch of different data sources and kind of comparing how the results change. So we considered current population survey voter supplement, the ANES pre-election survey, and an AP NORC VoteCast data. The problem is each one of these data sources has a flaw. So the CPS doesn't have those highly relevant ideology and party preference variables. But if you self-identify as a Democrat, I can pretty well predict who you voted for or whether or not you voted for Trump. Not perfectly, but it's a very strong predictor. So we'd like to have that. In the ANES, really great measures, but the sample sizes for some of the states are actually pretty small, right? Actually smaller than the poll data for some of the states. And then the AP-NORC VoteCast is an excellent data source, but it would not have actually been available before the election. And what we'd like to believe is this is a method you could actually do when the poll was conducted. So we can't be using the sort of data from after the election to do the adjustments. So we just decided we would compare using all these different auxiliary data sources. And the goal is to see under this method that we propose, we can see whether the non-response to the poll, the selection bias into the sample, is perhaps non-ignorable. So I'm going to really quickly kind of take you a little bit through the math, not a whole lot. There's details in a supplement to the paper. So we have our outcome Y, which is whether or not the individual planned to vote for Trump or already voted for Trump, because remember, there's a lot of early voting going on. We have auxiliary variables, the sort of typical demographics, and then the political party variables, and a selection indicator. You're answered the poll and you're a likely voter, or you're a likely voter who's not in the poll. So in order to use the trick of bivariate normality, which is computationally convenient, we introduce a latent variable U, which is you can think of it as a tendency to vote for Trump. And once you cross the threshold of 0, you're a Trump voter. So that's what you kind of imagine it as this latent variable. And once you cross the threshold, you are a Y equals 1. You vote for Trump. So what we do is we create this proxy for Y based on the covariate set Z that we have for everybody. This is essentially a data reduction technique. So we perform a probit regression using the poll data only to predict, yes, no, you voted for Trump using those demographic characteristics. So I can get a prediction out of that equation at the individual level for everybody in my sample. But I can also get it on the average for the whole population because I have Z bar for my whole population of likely voters. Again, I have lots of different sources I'm going to get that from, but one at a time, I'm going to plug in Z bar and it will give me my X bar, my proxy. So again, it's a data reduction technique. Really importantly in here is the proxy strength, which is how good is that probit regression model. So that is the biserial correlation between the binary Y and the continuous proxy X in the selected sample, which is just the correlation between the latent variable and X. And the higher that is, the more precise our estimates are going to be. So the basic idea is we can measure how much bias there is in X. Because I have X for everybody, I've constructed X for everybody in the poll, and I have X bar from the population. So I could compare the mean in the sample to the mean in the population and see whether there's evidence of bias in X. So if X, that proxy, is related to Y, then this tells me something about the potential for bias in Y. It doesn't guarantee there's bias in Y, but it tells me about the potential. So what we do is we assume a bivariate normal pattern mixture model. The one we use, we specifically call a proxy pattern mixture model because it's using that proxy variable X. The joint distribution of the latent variable and the proxy separate means and variances for the selected sample and the non-selected sample. So of course, this is an under-identified model because I don't have information about the distribution of the latent variable that underlies Y in the non-poll respondents, right? The people who are not in my poll. We can use this trick to identify this model by making an assumption about the selection mechanism. This looks really quite ugly, but really what we're saying is whether or not you are a participant in this poll depends on the proxy and the U, which remember underlies Y. So your demographic characteristics and whether or not you are likely to be a Trump supporter. In this equation here, we have this red parameter phi. So this is a sensitivity parameter. We can't estimate it. We just plug in a value and that implies an assumption about the selection into the sample. And then we can get out an estimate and we can compare and see what happens when we vary the sensitivity parameter. So if phi equals 0, the U drops out and response only depends on X. Only those demographic characteristics. Weighting should work in that case. If phi is greater than 0, then response at least a little bit depends on U, that latent tendency to vote for Trump. And in the most extreme, phi equals 1, doesn't depend on demographics, only depends on who you're going to vote for. That is unlikely to ever be the truth, but it is essentially a bound. So under this model, we do have two separate distributions for the people in the poll and everybody else. So what we want in the end is the overall estimate of the proportion voting for Trump. And it's just a weighted average of the proportion in the poll and the proportion of everybody else. Now for these polls, everybody else is huge compared to the sample. So we're really effectively just going to have that estimate. So where does the MUBP come from? Well, the MUBP says we're going to take an estimate out of this model for a particular value of phi, and we're going to compare it to what we observe in the sample. And this is an unweighted mean. This is treating this like a non-probability sample. And so if they're close together, there's not a lot of evidence of bias. And if they're further apart, we're going to get a larger difference. So in order to apply this to the data, we're going to be Bayesian. I'm going to put a uniform prior on phi. So we're essentially getting a range from ignorable to fully non-ignorable. And I'm going to estimate the mean for the different values of phi. And I'm going to ultimately actually just get out the I'm actually just going to show you these estimates of the mu hat y under the different the selection mechanisms. So one more time, though, about that auxiliary data, because this is really important. These auxiliary data sources that we're using are, number one, not without error, but we are pretending they are the truth. This is especially problematic for the ones that have smaller sample sizes like the ANES within the different states. The auxiliary data is also subject to non-response. So for example, the ANES had a response rate of about 61%. That there could be non-ignorable non-response going on there, and we're just pretending nothing. We're taking those weighted estimates as the truth. And also, all three of these sources give you different estimates of z-bar, right? You're the average, what the average likely voter looks like is different across these three data sources, and we don't know what the truth is. None of them are probably the truth if we're honest with ourselves. So that's sort of, we're ignoring that issue. Then secondly, we have this political ideology and party ID, very strong predictors of vote intention. The correlation in this proxy pattern mixture model, very, very high, 0.8, 0.9. If we take those measures out, for example, if we're using the CPS, or if we just take them out of the ANES or AP-NORC data, we get a much weaker model. Demographics alone don't predict vote intention, as well as, of course, sticking in political ideology. So these are the results. This is figure 1 in the paper. This is the 7 poll results from the ABC Washington Post polls. So I want to highlight for you first, the first 2 columns in each of these little panels is the estimates from the poll itself. The first one is unweighted and the second one is weighted. So where I have the kind of pink boxes here, the polls didn't actually miss, right? The polls are actually okay. Sometimes the weighting actually here in Florida moved the estimate away from the truth, but the weighted estimates, these are not huge, huge misses. Over here on the right, we have Minnesota, Pennsylvania, and Wisconsin, where we had much poorer poll performance, especially in Minnesota and in Wisconsin. Wisconsin in particular, huge, huge miss, right? Dramatically underestimating the support for President Trump. So I'm just going to zoom in on those places where there was worse performance, Minnesota, Pennsylvania, and Wisconsin really in particular. The first thing I want you to notice is if you look across the bottom, I'm going to tilt your head like this, we see 5 different versions of an MUBP adjusted estimate. We have when we use the NORC data using demographics only, the NORC data using everything, the ANES using demographics, the ANES using everything, and the CPS using demographics. And this is because we want to look at the comparison of the different data sources. So especially in Minnesota and Wisconsin, we can see the arrows are pointing to the demographics only estimates, and we can see this enormous ballooning of these credible intervals. And this is because of the weak proxy. When we take political ideology and identification out of the model, we simply cannot very well predict who you're going to vote for. If we use the data sources that have that better information, the NORC or the ANES with the political variables, we can see that in Minnesota and Wisconsin, where the polls did so poorly, our estimate using our sensitivity analysis is moving in the right direction, right? So we are shifting up those estimates of the amount of Trump support. Here, we did pretty well here in Wisconsin. That's a huge miss by the polls, and our estimate, the credible interval, covers the truth, right? So we are, in fact, if we had seen this beforehand, we would have said, there's some estimate we might be undercalling the support for Trump. So as a quick summary, the method did in fact sort of work in Wisconsin, where there was the huge polling miss. It detected that negative selection bias in Minnesota and Wisconsin. Sometimes, but not always, the MUBP adjustment is closer to the truth than the weighted estimate. We saw those widths of the intervals get really big, and it depends on the strength of the covariates. And importantly, I think this method didn't work all the time. right? The MUBP did not have any evidence. If you looked at that plot for Pennsylvania that I breezed through really quickly on one of those panels, the MUBP suggested no bias, but there was, in fact, negative bias in Pennsylvania. I also did not excerpt out of the paper. We also looked at some other polls in the US and a set of polls in the UK from the 2015 general election. And interestingly, the MUBP adjustment was much less effective in the UK polls than here in the US polls. So this underscores the need for quality information of the population margins for Z. So we're not there yet, right? Maybe we will never be, because likely voters is a really challenging population to try to quantify. This is a dynamic population, right? That is a population that isn't set until election day, right? That's a really challenging situation. This method can be applied in lots of different places, and in some applications it is much easier. So for example, I have a recent paper looking at using this method when we're trying to estimate COVID vaccination status early in the pandemic in the United States. That is a much easier situation because the population was stable. My target population, all US adults. I don't need a likely voter model, right? I can just use a large data set in the US, a high quality, expensive probability sample to get me those Z bar values. So that is it. So we can get to the question and answer. And I do want to say that Brady and I have tried our best to make the code to implement these methods as user-friendly as possible in our GitHub pages. It's unfortunately split in 2 different places, but there are examples and you can implement these methods yourselves. Thank you.
Thank you so much. That was fascinating. I was really struck by the number of different sources that you used to try to build your model out. And I wondered if you could talk about how you decided which sources to use and kind of what the process was for bringing those on board.
Sure, that is an excellent question. So the truth is, neither of us is experts in this area. And so we did not know what a good source was. And we were very flustered. And we had a nice set of reviewers at one point who gave us some hints, and you could try this. And we felt like the perfect data source didn't exist. Oh no, what do we do? And that's how we ended up comparing all of these different methods. So sort of CPS is the only one that we know we would have, but it's not a good source because it's missing the political ideology variables.
Oh, fascinating. It's sort of that argument about perfection is the enemy of good, right? Kind of looking for.
Correct.
That's terrific.
Yeah.
Thank you.
And actually for the UK data, it was easier because there was sort of only one choice. So in the UK polls, we used this British election study data, essentially the only place you would get those data from. And so there's not a comparison. It's just, this is our one source. And like I said, that didn't actually do very well.
Thank you. Maybe have any other questions? Let's just pause for a moment and see if other folks have anything to bring. All right, terrific. Thank you so much for your contribution today. And now we're going to end with some closing remarks. Back to you, Bella. When you're ready, we're ready.
Muted. I'm still muted, sorry. Yeah, so I would like to tell you a little bit about the research synthesis. This came about because the editors have felt that this perspective is missing from the collection of articles. So we were kind of tasked to put it together. And just shortly, you probably are familiar with the basic ethical principles for conducting research upon the premise of which, people participate, that we minimize harm and maximize benefit for individuals, ensure that the burdens of research are shared equitably among individuals that participate in research, and also that we ask for informed consent from research participants for their participation. And these are not new, these are not unique for these auxiliary data sources, but there are some challenges associated with auxiliary data sources linked to surveys, such as large volume and high granularity makes this data susceptible to confidentiality breaches. So basically, also, it is very difficult to anticipate the purposes for which the data, such as Paradata, administrative data, and contextual data are collected and used further down the line. So on the one hand, researchers may be uncertain about the appropriate conduct in digital social research. And in our synthesis, we give some examples of this ethical breaches that have happened in the recent years and what consequences it had. But also, on the other hand, the context in which we are conducting research is changing. So this is the current legislation, GDPR, General Data Protection Regulation. This is the EU and UK legislation, but in the US, similar initiatives exist. So it gives individuals knowledge, right to access, and the right to portability, so basically control over their data, if I'm not mistaken, Article 15 of the GDPR. So basically, people are also more knowledgeable about these issues. So we structured the research synthesis in 3 parts, and the first part was an informed consent, willingness to provide this consent to, well, linking or collecting such data, and privacy concerns. I have a quote here from a recent paper that says that, well, Americans do not understand what it means to consent to companies' use of their data, feel that they don't have control over it, and believe they're being harmed by the companies using the data. So how does it look like for research and for researchers? Because this can also translate. So from the literature that exists, and I'm cherry picking a little bit here in the interest of time, for Paradata, we see that people do not understand what Paradata is, and it's already some time that it's has been around, and it has been found that the respondents are less willing to provide well, answers to or participate in surveys if Paradata is mentioned, as found by Cooper and Zinger in 2011 already. But the article in our special issue by Felix Henninger and his colleagues also shows that respondents are less willing to provide mouse movements Paradata when they're requested sequentially, so after they consent to participate in the survey, rather than when they're requested in parallel to collect Paradata, for Paradata collection and to participate in the survey. But mentioning specific purposes, which one would think would promise more control to people, does not increase willingness, sorry for the typo, but can even decrease it. For administrative data, there's also concerns. So privacy and confidentiality concerns are cited as the main reason to decline linkage consent. And well, what can we do about this as researchers to frame it differently? For example, to emphasize gains that, for example, participants will spend less time if it's linked to administrative data, or emphasize losses so that the information provided in a survey would be much less valuable. But as we show, this framing has shown mixed results in the literature. So it depends on the type of data, it depends on how, the particular framing, and it doesn't necessarily increase willingness to link the data. Similar reasons, privacy concerns are also there for data collected with apps, sensors, and wearables. So high privacy concerns are associated with lower willingness to share this data, either hypothetical or actual sharing. Also, there have been some studies by myself and other colleagues that emphasizing privacy protection does not necessarily increase the willingness of people to share their data. We also touch upon that this willingness varies by task, and review studies which asked for understanding of the consent request for linkage to admin data and also digital trace data, for example, by asking knowledge questions or so-called quiz questions, true or false questions, to see if the respondents actually understand what the consent entails, what the consent request entails. And this understanding is not very high. What can be done, right, to protect people's privacy? That's another aspect that's a bit different from the willingness, but if explained to participants, it also can increase willingness potentially. And we talk about the data privacy utility trade-off, which basically is a concept that if the privacy protection is increasing, the utility of data might decrease. So, for example, if we are sharing data, right, with researchers for secondary use that is very fine-grained, then it imposes greater risk of de-identification. So greater detail is associated with greater risk for participants. And also linking to external data sources can be associated with greater risk. On the other hand, if we aggregate it, so for example, if this is data on geolocation and we just share the number of location participant has been to over half a year, then we can minimize the risk, but the utility of such data might be low. So what approaches are there that exist for protecting data privacy? And there are several that we distinguish between or among. One is the privacy preserving methods employed during data collection. For example, so-called privacy sensitive classifiers. Let's say you're collecting data about conversations, linking the survey data and data from apps. And it can be collected as a recording of the whole conversation, or it can be collected binary, conversation happening or not. So aggregating data on the device could help with privacy protection. Also for digital trace data, something which I work with a lot, local extraction can be performed. So basically GDPR, which allows this right to access, grants people, or thanks to GDPR, people can go to companies such as Facebook, WhatsApp, LinkedIn, digital platforms, but not only, also transportation companies, for example, that use electronic cards to tap in and tap out of public transportation. So people can request this data that works in the European Union, but also in the US, if you use in Facebook, for example, you can also request this. And then download this so-called data download packages. The extraction of data from these digital traces can also be performed locally on participant's device so that no data leaves it before it's aggregated. The second approach is adding noise or uncertainty. So there are already synthetic data sets, and we have some examples here from the US and from Germany that basically also help with privacy protection. Another approach is differential privacy. So it basically is the basic idea is that you can add noise to the data in the way that it ensures that the outcome of the analysis is nearly equally likely whether the subject is present or absent from the data. But there is, of course, a caveat that sometimes researchers want to work and access with original data. So in this case, one can restrict access or that, of course, then comes at a price of utility of data. Or work with virtual data vaults. And I have an example here from the Netherlands of SANE, which stands for Secure Analysis Environment, but there are also similar examples in other countries. So this basically ties together, our research synthesis ties together the reasons for people's concerns or non-participation, also what can be done by the researchers protecting privacy of participants. But I don't have a concluding slide, but I want to conclude that this, privacy concerns and reasons for non-consent, non-willingness, non-sharing are not yet very well understood. They are very often cited as reasons for non-consent, but whether people actually understand what is requested from them and what will actually help them to provide truly informed consent, this is still very much, I think, a moving target that we would need to conduct research on. I want to stop here to have some time for discussion. And since all of these articles are published, available, I encourage you also to read up if you're interested. Thank you.
Terrific. Thank you so much. I think you brought up some really important points there. One of the things that we kind of struggle with is this idea of the hesitancy to link data from the same respondents who will freely share data with for-profit companies, as you were talking about social media and other sorts of organizations. And we kind of wonder if it isn't the requester, if there isn't like a layer of hesitancy that's baked into who's asking for the data linkage. I wondered if you could talk about that.
Oh, I get this. Thank you so much for your question. I get this question asked a lot, actually. So why are people providing their data, sharing their data freely on this social media, but then when researchers are asking for consent, then they act differently? Well, I would invite you to look into research or conceptualization by Helen Nissenbaum of privacy in context, where she argues that information is not inherently private or public, but it depends how the person perceives it and well, what, for example, they think the audience is, right? And how they think the data will be used and so forth, which shapes their decisions about sharing. And there is, well, she has given a lot of talks, but I'm just sharing a website of the MAS workshop, which myself and some other colleagues organized, where last year she gave a keynote on specifically this topic, which would probably give some more information than I can in this short answer.
Oh, terrific. Thank you so much. All right, let's just take a moment and open up the floor. Does anyone have any questions they'd like to pose to anyone from our panel today? I'll say one of the threads that I saw going through all of these presentations is how this really is a frontier of survey research, that we're sort of moving into new and emerging technologies. And I wondered if you could just take a minute. I know this is a big question, but kind of take a minute and think about where are we headed? What do you think is the next kind of big breakthrough with this alternate sources of data that we can link to our surveys? Anything come top of mind? How's that for a dissertation question?
Well, if no one if no one wants to answer, I think that this is for one, this is very exciting, right? Because this is all yeah, moving very fast. And I think what happens basically is that the more and more sources are being combined, not just what we also have the papers that we have in our special issue, but also, for example, probability and non-probability data, right? So there are statistical approaches which are being developed as we go. There are new approaches in data collection as we go, and this all needs to work together. So I think this is also where the excitement comes. Yeah. But at the same time, there's also legal and ethical aspects. Sure. So for example, for this digital trace data collection, I'm working together with lawyers or law scholars, I should say. And this is eye-opening to think about it in a new way. So I think like this truly interdisciplinary perspective and well, the wealth and breadth of research that it allows to conduct especially is very exciting, valuable.
For sure. Thank you. All right, I'll take our last few minutes to close us out. Thank you so much to our guests today for your time and incredible insights. And thank you to everyone for making today a success. The recording of today's event will be available on the DC-AAPOR YouTube channel in the next few days. Just a heads up, our next event is a book club session scheduled for April 24th at 12 noon Eastern. We'll be hearing from the editors of the book, Survey Data Harmonization in the Social Sciences. Sure to be a good one. You can sign up at our Eventbrite page. On May 1st, we're going to be hosting a happy hour at Mission Bar in DuPont Circle. We're especially interested in inviting new DC-AAPOR members who might want to get to know folks prior to the annual conference in Atlanta this year. If you're not headed to the conference this year, this happy hour is also a chance to recreate some of that conference magic here in DC. We're also going to be introducing our new DC-AAPOR Executive Council at that event, May 1st at Mission Bar. It'd be great to see you there. And finally, save the date. The annual DC-AAPOR WSS Review Preview Conference is scheduled for September 24th at the National Academies of Sciences in Washington, D.C. with a happy hour to follow. So hope to see you there. Thanks again to all of our speakers and organizers today, and have a great rest of your day. Cheers. Thanks for your time.
Thank you so much,
Thank
Melissa.
you.
Thank you.
Thank you. Bye-bye.